Hello, everyone. I hope you are doing well. I'm glad to speak to you today. I am Krzysztof Piaskowy, but Polish pronunciation is a bit strange, so you can call me Chris. Okay, but I am working at Software Mansion as a React Native open source developer. I am also maintainer the Reanimated library, and that's why I'm talking about animations. This talk, I would like to start with a story about this gentleman. Meet Tomek, yeah? Perhaps he's sitting somewhere here, and Tomek, together with me, work on Reanimated, and we have a lot of fun with it. Tomek usually arrives to the office earlier than I do, and his desk is right next to mine. One day, I came to office, I look at Tomek, he look at me, and he starts to smile, but with very specific type of smile. I mean, this specific type of smile. And I know that he did something big. So then Tomek called me to come over to his desk because he wanted to show me something. And he showed me this. Give me 1 second. OK, this nice billiard game. OK, and also show me this one labyrinth game. And I was surprised what he was able to do just in React Native. Until that moment, I always thought about the games as something that required native programming rather than JavaScript. But what I saw, it wasn't enough for me. I was hungry for more. I have started to think about something a bit bigger, about this. But bad news, unfortunately, Tomek didn't do it. So I need to went back to my desk and started thinking about the future of React Native. Then I asked myself, perhaps the one most famous question in React Native world, can it be done in React Native? And in this particular moment, I didn't yet know the answer for that question. So I started to look around, and my first discovery was ExpoGL. So ExpoGL is a library that offers you GL view, which acts as a renderer target for OpenGL. In simple terms, GL view is visual display that presents the output from GPU, which is computed by the shaders. So ExpoGL is built on top of OpenGLS, which is natively supported on iOS, Android, and even on web. That means it doesn't require any additional heavy dependency to run it. Moreover, ExpoGL is also compatible with WebGL API, which provides you access to a wide range ready-to-use shaders that are available on the internet. With ExpoGL, you can directly use those shaders to create impressive visual effects directly in your application. But what are the shaders and how to use them in the app? So basically, a shader is a small program that is running directly on your GPU, and it doesn't mind the bitcoins, yeah? OK. Basically, there are two main types of shaders. Vertex shaders that calculate the position of elements or triangles, and fragment shaders that compute the color for each pixel. But for the simplicity, let's focus mainly on fragment shaders. Fragment shaders are essentially functions that take pixel coordinates as input and return the new value color for this pixel. However, there are two additional key characteristics for those functions. First, they are run on GPU instead of CPU, and they are run in parallel. So each shader does compute in same time for same pixel. So you can basically run it in compute new graphics in real time. But let's jump to the example. We have a picture that is used as input data for the shader. Each shader takes one pixel of this photo as input, and its job is to add a little bit red to each pixel. The outcome is an image with a red mask applied to it. But it's just a theoretical explanation. How does it work in practice? So let's take a look at the same scenario I explained before, but this time with the actual shader source code. Here, we assign the original color of each pixel in the photo. In effect, we ended up with a photo that is exactly the same as the original photo. Let's modify it a bit. We are going to modify each pixel, but adding some red color to it. To do this, we need to use vector, which contains RGBA value for each color channel, with the value range from 0 to 1. And final result will be exactly the same as the red mask image I showed before. Shaders are essentially clever mathematical equation. To achieve slightly different effects, you can modify previous shader but making the red channel value depend on the scene of the x coordinate. As a result, we get some kind of wave pattern on the image. But if we modify shader enough, we can achieve even effects like this. This is still shader. I am so impressive what is possible to achieve with just shaders. OK. And just quick recommendation. If you want to practice writing your own shaders or just need some inspiration, you should really check Shader Toy. This is an awesome website for that kind of stuff. But how to use it in application? Yeah? To find out, I started playing around further with ExpoGL. I wanted to create 3D shape, so I thought a 3D cube would be a good starting point. And I began with setting up the application. I was able to set up with just 2 commands, and I was really surprised because I thought I would have to do a lot of strange configuration to get running it with 3D graphics. Yeah, but it was actually really easy. At the beginning, I didn't know how to start, but then I remembered that ExpoGL implements WebGL standard, yeah? Where in internet you can easily find a lot of useful resources about WebGL. So I was able to write some code that let me show the cube in app without much effort. Basically, if you want to display a cube, you need to do 3 things. Create GL view that will display the output from the shader. Then you need to compile the vertex shader responsible for the position of the cube. And finally, you just need to add this shader to GL context. And the last missing part is to write the shader itself. Pay attention to the input matrix parameter, which controls the cube orientation in space. It's just some math. Just displaying, but to be honest, just displaying a cube is so boring. So let's add some animations. But we want smooth animation. We don't want running animation on busy JavaScript thread. But the solution is simple. We will use Reanimated. Yes, the ExpoGL is integrated with Reanimated. This allows us to update the GL context directly from UI thread without any delays. To run the animation, we need just 2 steps this time. First, we need to create shared value and just start animation. Simple. Then we need to update the matrix parameter in every frame of animation. The matrix presents the projection matrix of the cube. To update shader parameter, we need to, 1, get the pointer to shader input parameter. 2, calculate the new projection matrix. Yeah, that's point 2. And 3, update the value inside the pointer. Since ExpoGL supports Reanimated, this also means that we can use gesture handler directly from UI thread. Here, the code is almost identically to previous case. The only difference is that we are using gesture handler and modifying projection matrix in 2 different axes instead of just 1, like before. What are benefits of having other libraries integrated with Reanimated? As it's known, Reanimated is running on UI thread. Yeah, it's running on UI thread. That means you don't need to send commands through the bridge and serialize and then deserialize it. We also can react faster to event and gestures. Additionally, if the JS thread is busy, we still can calculate smooth animation, so we don't lose frames. But going back to the example, let's think about how difficult it is to achieve such effect. Basically, you need to know some math. I mean, this. So that's the piece of math responsible for rotation the cube. Personally, I like math, but I can imagine that not everyone is really into it. But math is not all what you need. The vertex shader needs to know the coordinates of each vertex. So you need to provide them. Doesn't look really friendly. Yeah. But here is also good news. So we don't have to manually define all vertexes. We can simply load the file that describes the 3D model and display it without writing own shaders. And here comes Three.js, which provides a much simpler API for manipulating 3D objects. The Expo team has bridged Three.js to make it possible to use it in React Native by creating Expo tree package. This allows developers to take advantage of features that Three.js contains. It was possible due to Three.js uses WebGL context provided by ExpoGL library. The fact that Three.js is a powerful tool is proven by advanced and so impressive examples presented on their websites. So we already have idea how to display objects using plain ExpoGL. We know this is so powerful tool, but not the easiest one. It requires knowledge about the GPU, about shaders. But what about using Three.js to achieve the effect shown on screenshot? Basically, we only need to load file with description of the model and display it on the Canva. Simple and beautiful, right? But let's take it a step further. Let's add to it a bit of gesture handler and Reanimated. It's just a matter of reading the gesture information received by the gesture handler, then modifying a simple property on the mesh object, and that's it. I think it's quite simple. The example that inspired me comes from those tweets. It's great to see people sharing such inspiring idea. Let's see how it works. So this example uses a use animated sensor from Reanimated. OK. Taking the opportunity, I need to tell something more about Reanimated. I would like to show you a few great examples of using this hook. It may enrich your user experience of your app and allow you for creating 3D movement illusion. Yeah. Also, this time, also, people were happy to share their idea. Let's take a look at on this, this, or this. OK. I would love to see how. I would love to see more apps with this kind of features. For me, pretty awesome. OK. It's hard to not mention another great tool that has gained more popularity recently. William has proven today, and not only today, that using Skia you can paint like Bob Ross. Yeah, so it's hard to add more here. Yeah, but I just want to mention that Reanimated is integrated with Skia also. How to add animation to Skia component? The answer is super easy. Yeah. You can directly pass the shared value from Reanimated as a property, in this case, the radius, yeah, and just animate it. Then you can enjoy smooth animation running on UI thread. But what about gestures? Of course, it's also possible. One of our software mention open source goal was to provide a single, consistent, and simple API for gestures and animations. Now, all you need to know is just the API of Reanimated and Gesture Handler. And you can simply use it in many different scenarios with different libraries. With Skia, Reanimated and Gesture Handler, you can make an awesome effects like this one, or even this. The presented example, of course, I took from William's channel. If you want more content like this, I really recommend you to visit William's YouTube channel. Before I finish, on behalf of the open source team at Software Mention, I would like to say thanks to Shopify for their continuous support over the last few years. I would love to have them as part of our community, and we appreciate all they do to driving this technology forward. And that's it. I hope I inspired you to give free animation a try in your application. I think that 3D technology is a large untapped potential in React Native world. Don't be afraid. Try to make your app stand out from the crowd. And remember, you are awesome. Thank you.